Okay, so hi one more time. Good to see you. So we were talking about similar triangles, and this is our third lesson about similarity or similar triangles. And today we are going to talk about the application of similar triangles. Application means, of course, it has a lot of applications, and also actually the idea of trigonometry, it's based on similarity from similar triangles. And especially um, proving theorems, Mr. Dashel. Hello, Dashel, can you hear me?
Yes, sir.
How are you?
I'm fine, sir. What about you?
I'm okay. I'm doing great. Is it also rainy season in Philippines now?
A bit. There's gonna be a rain in a while.
Hmm, I see, but here in Cambodia it's raining a lot these days. Did you start your school or not yet, Dashel?
We have started like last week.
Hmm, good. Online, right?
Yes, sir.
Or, I see. Okay. All right, good. Dashal, good to see you again. All right, as you know, we were talking about geometry, one topic, geometry, that's about similar triangles. And usually standard questions are not so hard, right? Because you're just using a simple rule or property. We know that if two triangles are similar, that means that their corresponding angles are equal. Then also we have some properties, right? If two triangles are similar, that means that their corresponding sides are proportional. But in math context, sometimes it may not be easy to see. Here, if you see, if you're thinking about a bunch of similar triangles, not only two, like three, four, five at the time, problems may get more complicated. Okay. So another important thing in dealing with geometry questions is accuracy. You have to draw accurately, okay? Sometimes students draw parallel lines, which actually they don't look like parallel lines at all. And after that, it may cause some, or it may lead to some confusion, okay? And that's the challenging part of geometry, because if you do not draw your figures accurately, but at least maybe not to scale, but accurately, so it may lead to some confusion and students get confused and we may not be able to get the correct answer. Okay, so anyway, let's just have a look at these things, and after that we'll try to solve a few questions, and also if possible, really I want to have a discussion and get your idea about the problems. So number one is to prove AB is equal to CD. Okay, sometimes in a lot of cases in math, if you're proving something, okay, we may not have to prove it directly. Okay, we just find a connection or equivalent expression. Okay, we just try to prove the equivalent one, and after that it implies the original problem. For example, in the first case, that's what we're talking about here. If AB is equal to CD, suppose that we have to prove that A times B equals C times D. So also we can, by applying a bunch of algebraic operations, I may try to obtain this AB and CD. Or actually, if AB equals CD, these two expressions, right, or proportions, actually they are equivalent to each other. So that means that if you divide both sides by, what is it, B times D, I get this one. A over D is equal to C over D. Or simply, I'm taking D to the left-hand side and B to the right-hand side. That means that proving that AB equals CD is equivalent, the same as proving that A over D is equal to C over B. And also for the things, how about a squared over b squared? Suppose that we have to prove that that's equal to c over d. Or a cubed over b cubed equals c over d. Or a times b times c over d times e f is equal to k. So we often transform them as products of several expressions, right? Like a squared over b squared. What is it? It is a over b times a over b. Or a cubed over b cubed. That's a over b times a over b times a over b. And then we try to find what is a over b. And after that, we can just cube and get the answer. For example, here we have a squared equals b squared. A squared over b squared equals c over d. Suppose that we have to prove this, okay? Okay, directly I try to get the expression like this. And also another way, if I can find something, let's say a squared over b squared is equal to c over x, right, as shown here. And also, not a squared, b squared, a over b. And also a over b, let's say also is equal to, what is it, x over d. As you see here, if you just multiply side by side, a over b times a over b. Our first a over b is equal to c over x. Our second a over b, actually they are the same thing, that's equal to x over d. Now if you simplify this, we will get c over d. And also in this way, we can actually prove that a squared over b squared is equal to c over d. And what is the point here that we have to pay attention? As see here, we have some kind of, what is it, middle term here, that x. It is something here, okay? Actually, we don't have to know the exact value of this x. It can be anything, okay? The problem here is I'm just expressing this a over b by c over something, and a also over b by x over something d. Right, so that when we multiply this, it's gone. That's why we don't have to know the exact value of this x. Now, from these examples, it may look a bit easy, but of course, as seen, when math problems get more complicated, if we have to apply a bunch of different concepts to a single problem, that's the challenging part. If you're just using a single rule, right, usually it is easy. For example, if you're solving a quadratic equation, right, let's say here we have a x squared plus b x plus c is equal to 0. And just follow this fixed rule, we can solve this, right? Number one is find the discriminant, that is b squared minus 4ac. I know how to find this. After that, write the first root. If it is non-negative, what is it? It is minus b plus square root of delta over 2a. And here we have x2 equals minus b minus square root of delta over 2a. If you just follow these steps, okay, the first step and the second step and third step, you will get this solution. And solving this kind of problems, it is easy. But if you have to apply maybe a bunch of different concepts, okay, some from similarity, some from algebra, some from maybe trigonometry, at that time things get more complicated. Okay, here some questions may be a little complicated, Mr. Desha. So if it is complicated, again, one just single question, you have to draw accurately and try to understand what's going on here. And of course, if you really understand, you will enjoy learning, because as it gets harder, you will get more interested. So the important thing is not giving up. Anyway, let's start with this question. Example 1. Here it says that AD is an altitude of acute triangle ABC. So acute triangle ABC, what we mean by this, that means that all the angles, right, interior angles of triangle ABC are acute angles. Acute means an angle that is greater than 0 and less than 90 degrees. And also it says that CO is a point, right here, O is a point on AD. So AD is a height, right, altitude. That means that the angle ADB is equal to angle ADC. That's equal to 90 degrees. Just keep in mind. I don't want to write this, otherwise it will be confusing. That's why I don't want to draw here the angle. So, and after that, it says that connects BO and CO. So here we have O is a point on AD, and we just connect this with BO and also CO. And after that, also we extend this line, okay, and produce this until it meets the line segment AB. So it meets the line segment AB at F. And also BO meets the line segment at E. And the question here is, prove that the angle EDO, let me just write here, EDO. What is EDO? It is this angle, right? Prove that this angle is equal to angle FDO. Okay, we have to prove that this is equal to this angle. Okay, they are equal. Okay, so that's the question. And see here we have a bunch of lines, and just drag this. I mean, seeing the relationship, it's not easy. That's why if you draw your figure so small, you may not be able to see actually maybe the similar triangles or something, whatever it is. Okay, so after that it may get more confusion. That's why when you're doing geometry questions, if the problem is a bit complicated, you have to draw as big as possible, of course, if you can. So after that, label the things well. And also here it says that AD is a perpendicular to BC. That means it's an altitude. Also, actually, it must be clearly seen that it forms a right angle. Anyway, how we are going to prove this? Okay, first to prove this one, actually, if I just draw another line, okay, I'm just adding a line to this, RS. Okay, if you just see, let me just use dark right here. I'm talking about this. This here we have R and S. I'm just joining a line that passes through O, and also that is parallel to BC. Okay, I'm just drawing a line that is parallel to BC or BD. Okay, so it passes through O. Also, actually, it crosses at actually FD somewhere. Let's say this point P, and also crosses DE somewhere. Let's say this Q. Okay. So now, proving that this angle, let's say that this is alpha and also alpha, we're going to prove this. I don't know yet, okay? To prove is the same thing as proving that PO is equal to OQ, okay? If I can prove that PO is equal to OQ, what does it mean? It means that if we draw a triangle, right? And if you just draw any height here, right? This height, if this thing equals this thing, that means that these angles are equal. These angles are equal, which means that and also these angles are equal, right? From here, because it's an isosceles triangle. When it's an isosceles triangle, then if you do an altitude, it bisects the base. That is actually this line 7 is equal to this. That's why using this idea, okay, first I'm going to prove that PO is equal to OQ. If I can prove that PO is equal to OQ, that implies that angle ADF or ODF will be equal to angle ODE or EDO. Okay, that's my approach here. Okay, so now after drawing this, okay, we just joined this RS. Okay, so after that, if you can see that, now we're going to prove that PO is equal to OQ, and since RS, let's see here, RS is parallel to BC. Now we can just write some similar triangles. If you look at the triangle FPO, what is FPO? FPO, right, is similar to FDC. What is FDC? FDC. Why? Because this line is parallel to this line, right? And as you hear, this triangle FPO and is similar to FDC. I can write a few more triangles. And also at the same time, if you look at this, for example, OEQ, right? That is similar to actually it's similar to BED. And also here we have FRP. What is FRP? Here we have F, and here we have RP. Also that's similar to FBD. In similar, you can write others, and I don't need them actually. You can just, for example, EQS is similar to EDC, right? And also this triangle, what is it? Yeah, that's it. I think that's enough. So now using the rule again, the property that if two triangles are similar, that means that their corresponding sides are proportional, right? Now from here, FPO is similar to FDC. That means that FP over FD is equal to PO over DC equals FO over FC. So here we have PO corresponds DC. That's why PO over DC equals FB. What is F it should be not FB, FP, right? FP, FD. Let me just correct it. The middle is FP, it's not B. Okay, FP over FD equals and the RP, what is RP? RP over BD. What is RP? RP is RP, right? RP over BD, because the ratios are the same from here. FP over PD is equal to RP over BD, right? So, and also now we can just write this, the second one, because PO plus RP. What is PO plus RP? PO plus RP is just OR, right? Let's see here, this triangle FRO is similar to FBD. So instead of this RO, we are just writing here RP plus PO, or OP plus PR. So PO plus PR over, actually here we have BC and DC plus BD. So that is actually this, what is it? In triangle FRO is similar to FBC. That's why here we have RO over BC is equal to FR over FP, or FP over FD, right? So anyway, that's equal to RO over BC, and also that's equal to PO over DC, PO over DC. Now we are just going to combine these things, okay? So let's continue here. Similarly, the second one, here we have OS, right? Because now we are writing this triangle OES, and also that's similar to EBC. So OS over OQ, OS over OQ is equal to BC, what is BC? BC over BD, BC over BD, because here we are talking about EBD is similar to EOQ, right? EOQ, this one is Q, actually, this one is O. And the RO, that's RO over OS, again, RO over OS is equal to BD, BD over DC, it's ratios. Anyway, now if you just combine these things together, so here we have PO over RO times OS times over OQ times RO over OS. So PO, and instead of this ratio, we can write BDC over BC times BC over BD times BD over DG, and that's equal to 1. Now from here, by simplifying this, we can get that PO over OQ, right? Because OS, they cancel each other. RO, they cancel each other. This RO, and OS, they cancel each other. PO over OQ, that's equal to 1, which implies that then PO is equal to OQ. Okay. But usually here in explanation, I had to use these capital letters, but instead of this, if you just label this size by some lowercase letters and write your ratio, they may look a bit simpler. Okay. So since actually PO is equal to OQ, that means that POD, this POD is congruent to ODQ or QOD. They are congruent to each other, which means that angle PDO is equal to, or EDO is equal to FDO. Okay. Another example, example 2, in triangle ABC, AB is equal to 425. So this AB is equal to 425, and BC that's equal to 450. BC that's equal to 450. Let me just write here this BC. 450. Okay, and AC that's equal to 500. So this AC 510. Okay, AB that's 425. 425. Okay. Anyway, P and Q are points on AB. So see here, this P, point P, and point Q, they are points on AB. And R and S are points on BC. R and S, they are points on BC. and T and U are points on AC. And also it says that PS is parallel to AC. That's PS parallel to AC. So this line segment is parallel to this line segment. And QT is parallel to BC. So this QT is parallel to BC. And RU is parallel to BR. So RU is parallel to BR. So let me just write here this 1, 2, 3 is parallel to 1, 2, 3. Okay. Anyway, so QT and QT and RU meet at a point O if the length of PS, QT, and RU are D. So here it says if the length of PS and QT and RU, they are equal to D, find the value of D. So we have to find the value of D. So here we have PS is equal to QT is equal to RU, that's equal to D, right? What is PS? So here PS, if I just write with letters, it will be confusing. That's why I'm not going to write this. And QT, what is QT? QT, right? And also RU, this RU, they are equal, and this is equal to D. So we need to find the length of, the numerical value of D. Okay, let me just relate this. Now we know their values. So it will not be so confusing. Okay. So now from here, actually, what we know here is it is revealed that we can see obviously that PO, you see here, PO is equal to AU, right? Why they are equal? Because PO and AU, they are parallel to each other, right? You see here, APOU, it is a parallelogram. Parallelogram is because AP is parallel to OU and PO is parallel to AU. That means that if we are given a quadrilateral where opposite sides are parallel to each other, we call it a parallelogram. And we know that in parallelogram, opposite sides are equal. So from here, PA is equal to OU and AU is equal to OP, right? At the same time, also QO. If you look at this, here we have QO, right? QO equals BR, and also actually Q or O Q BR, also it is a parallelogram. That means that actually this side, right, is equal to this side, and also this side is equal to this side. And also here, let me just write instead of this one, okay? So here we have this side equals this side, and this side is equal to this side, okay? And also a similar way, OSCT, also actually it is parallelogram, right? So OT is equal to SC, and with 3 maybe, 1, 2, 3 is equal to this side, and also 1, 2, 3, and 1, 2, 3. And they are parallelograms. All of them are parallelograms, okay? So what is next? Next, now from here, let's find PQ. What is PQ? PQ, right, this PQ is equal to AB minus AP minus QB, right? That is AP and BQ. Now from here, that's equal to AB minus, what is AP? AP is equal to UO or OU, right? And plus, what is QB? That's equal to OR. So from here, we can write AB, we know AB, that's equal to 425, that's 425, minus, what is UO plus OR? UO plus OR, that's equal to D. So 425 minus 6. So now we have expressed PQ in terms of D, okay? So in similar way, how about RS? RS, let's just find RS. RS is equal to 450, right? Minus SC minus BR, and BR is equal to OQO, right? And also SC is equal to OT. So actually this length is equal to D, that's why TU is equal to 510 minus, RS is equal to 450 minus D. And how about TU? Here we have TU again. TU is equal to AC minus AU minus TC. and AU is equal to RO, right? And TC is equal to OS. And what is PO plus OS? That's equal to D again. And that's why this TU, actually this TU is equal to 510 minus D. So actually this equals 510 minus D. And RS, this equals 450 minus D. And how about PQ? This PQ is equal to 425 minus D. Okay, they are equal. So now, since if you look at this AQO, right? This AQO, right? AQO is similar to ABC, right? And here we can just write here AQO. I can just join this one. You can just join this triangle because QO is parallel to BC. That's why AQO is parallel to BC. That means that we can write this ratio then AQ over AB equals AO over BC equals QO over BC. That is PO over PQ. That's equal to AC over AB. Okay, so AC over AB. What is we have PQ? PQ. No, not AQ or PQ or PQO. Let's see. That's right. It should be not A. Also, AQO is also similar, but I need PQO here. Okay, I need PQO. So PQO is similar to triangle OABC. So now from here, PO over PQ is equal to AC over AB. Okay. So now we can just write from here, if you just find PO, because in the previous one, from what is PO? PO equals AC over AB times PQ. And if you just substitute the expression for this, AC over AB times PQ, what is AC? 510, AB 425, PQ 425 minus D. And if you just expand this, and 425 gone, 510 minus 6 over 5D. Because if you simplify this, it is 6 over 5D. In a similar way, ORS is similar to ABC. ORS, right? Also, it is similar to triangle ABC, which means that OS, right? OS over RS equals AC over BC. Because since it is similar, actually, I can just write this ratio OR over AB is equal to RS over BC equals OS over AC. Now see here, if I just take this to this side, right? AC goes here, RS comes down, right? OS over RS is equal to AC over BC. Anyway, so after that, again, we can just find OS. What is OS? OS is AC over BC times RS. We know what is AC, that's equal to 510, and BC, that's equal to 450, and RS, we have already found this in terms of D, that is 450 minus D. So if you just expand this, we have 510 minus 17 over 15 D. So since PO plus OS, right? PO plus OS, that's equal to D. So now we can just write here, we have PO, that's equal to 510 minus 6 over 5D. And also OS, that's equal to 510 minus 17 over 15D. And we can just substitute here. What is PO? That is 510 minus 6 over 5D. Plus, what is OS? OS is 510 minus 17 over 15D. On the right-hand side, we have D. Now we have just a linear equation, and by solving this, we can get the value of D, because 510, right here we have 510 plus 510, that is 1020. And minus, we have to add, what is it? 6 over 5. 6 over 5 plus 17 over 15. 17 over 15. 6 over 5 plus 17 over 15. So that's equal to 7 over 3. 7 over 3d. That's equal to d. And take 7 over 3 to the right-hand side. D plus 7 over 3d equals 1020. And 1 plus 7 over 3, that's equal to 10 over 3d. That's equal to 10 times 102. So this 10, 10, it is gone, right? What is d? D is equal to 306. Rachel, is everything okay?
Yes, sir.
Rachel, what are you learning now in your math class at school?
We just had like an orientation
Orientation.
from last week. Maybe the lessons would be this week.
So now you're going to grade 9, right?
I am grade 9 now, yes.
So you will study for 11 years or 12 years?
Come again, sir?
I mean, Philippines, the school, you have to study for 11 years or 12 years?
I mean, we can reach up to grade 12. And yeah, I think that's what you mean.
Yeah, because for example, here in primary school, 6 years, and secondary school, 6 years. Then you can go to university.
Yes, sir.
Same?
Yes, sir.
Good. Okay. Okay, now let's see another example. Originally, actually, these dashed lines are not given, but I was just going to draw without this, and this is given, that's why I'm going to use this figure. In this question, it says that let the area of parallelogram ABCD be 1. So the area is 1. E and F are midpoints of AD and CD respectively. So that is a parallelogram. That means the opposite sides are parallel. AE and ED, they are equal. Since the midpoint, immediately we can just write here a solution. Let's say the given information was given here. AE is equal to ED. And also CF is equal to FD. They are equal. Even I can just write here like this. They are equal. Anyway, E and F are midpoints of AD and CD respectively. AF meets EB, right? EB at EB and EC at P and Q respectively. Okay. We have to find what is the area of triangle EPQ. Okay, so what is the area of triangle EPQ? Well, I'm just talking about this small area, so we have to find this area. Okay. So to do this one, we have some properties of parallelogram, but you can just prove that the sum of the area of AEB and the ECD is equal to the area of BEC, for example, and also the ratios, blah, blah, blah. Anyway, before we start this, okay, just what we analyze here, that first, let me just draw a perpendicular line from P to AE and from Q to ED. Okay, so these lines, actually, they are perpendicular lines. And after that, let me just produce the line segment AF, okay, until it meets the extension of BC. So they actually meet each other at this G, okay. So, all right. Now, let's find actually here, and it says that find the area of triangle AEQ, AEQ, and also triangle AEP, okay? So if you know their areas, then their difference gives us the area of triangle EPQ, because the area of AEQ minus the area of AEP gives us the area of, what is it? Triangle APQ. So triangle, let me just write the triangle, area of triangle EPQ, EPQ is equal to the area of triangle AEQ, AEQ minus the area of triangle AEP, AEP. So if I know these two areas, right, we can just find the area of the thing. Okay, to do this one now, actually after drawing this, what is it? The height from P to AE and from Q to ED, okay? And after that, I'm also producing the line AF and BC so that they meet each other at G. So we can see that AEQ, right? You see here, AEQ is similar to, what is it? GCQ, GCQ. Why? Because these angles are vertically opposite angles, they are equal. And since CG is parallel to AE, right? And this angle, let's say this angle is equal to this angle. And that's why these two triangles are similar to each other. And also triangle AEP, AEP is similar to triangle GBP. For GBP, here we have triangle GBP. Why? Because BP, right? AEP, AEP, and the AEP, GBP, AEP. Okay. AEP, GBP. Okay. AEP, GBP, because it's a common, what is it, BP and the PE, they are collinear, that means that they are similar. And also this angle, right, these angles are vertical opposite angles, and this angle, let's say this angle is equal to this angle. That's why these two triangles are similar. Okay, just write here the GPP, it must be triangle. Okay. So now since actually these two triangles are similar, now we can just write here that AEQ, GCQ, right, from this similarity, then write that AB is equal to 2 times FC, right? Why 2 times FC? Because AB, right, and also if, let me just write here, if CF is equal to X, and also this one is X, then AB will be 2X. For example, AE is equal to Y, ED is equal to Y, parallelogram opposite sides, so BC will be 2Y. Okay. So that's why AB is equal to 2 times FC, and AB is parallel to FC. And also that's why BC is equal to CG. What is BC? So here we have BC is equal to CG. Okay, because and just extending this, and what is it? If you just draw the line, so this will be also 2y, because this x over 2x should be equal to 2y over bg, right? I don't know what is it. That's why, since it is 2y, also it should be 2y. So now let me just introduce some small letters to represent this height. Let h be the length of altitude A, B, C, D. Okay, and on BC. So we are talking about this altitude. We are talking about this one. Okay, let's say it is h, and h1 be the length of altitude AEQ. So AEQ. So this one, let's say this h2, and that's h1. H1, and H2 be the length of altitude of AEP. So this one is H1, actually. The altitude is H1, because these are altitudes. Okay, these are altitudes. Okay. So then the area of AEQ. What is the area of AEQ? It is height times base, right? That's equal to 1 over 2 times AE times H1. And how about the area of AEP? Again, is equal to 1 over 2 times AE, its base, times H2. So see here 1 over 2a, 1 over 2 AE, 1 over 2 AE, they are the same thing, right? And since triangle AEQ is similar to GCQ, now from here we can write that AE equals half of GC. So from here, H1 is equal to 1 over 3H. In a similar way, triangle AEP is similar to triangle GPP. Triangle AEP, right, is similar to GBP. And that's why AE is equal to 1 over 4 GB, which implies that they are similar. H2 should be equal to 1 over 5H. So now we have expressed this H, H1 and H2 in terms of H. So now if we just substitute there, then what is the area of EPQ? That's equal to the area of AEQ, the area of AEQ, minus the area of AEP. And the area of AEQ, that's equal to 1 over 2 times AE times 1 over 3H. The area of AEP, 1 over 2 times AE times 1 over 5H. And since this 1 over 2 AE is a common factor, we just keep this outside the parentheses. So 1 over 2, what is AE? AE from here, right? AE is equal to 1 over 2 times AD. We have already found this in the previous slide. And how about if we simplify this, 1 over 3 minus 1 over 5 is equal to 2 over 15H. So if we simplify now, that's equal to 1 over 30 times AD times H, right? What is AD times H? That's equal to 1, because AD is one side of the parallelogram, and H is the height, because the area, actually the area of parallelogram ABCD is equal to AD or BC, that is AD times H. And in the question, it says it's equal to 1. And that's why here AD times H is equal to 1. So the area of triangle EPQ is equal to 1 over 30. Okay. So we have 3 examples. Now we have, I think, 7 questions in exercises. Let's try to solve some of them. I don't think we'll have enough time to solve all of them. So let's start with this question. Prove the theorems of angle bisector, or the theorem of angle bisector. If you remember, what is the angle bisector? If you're given a triangle, and suppose that this AD is an angle bisector, that means that this angle is equal to this angle. And suppose that this side is opposite B, it is B opposite C, that is C. Let's say BD, that's equal to, actually this DC, that's equal to M, BD is equal to N. This angle bisector says that if we have B over C is equal to M over N, or that's equivalent to this, B over M is equal to C over M. Okay, so that is the angle bisector theorem. So we have to prove this. And of course, there are some different ways of proving this using trigonometry and blah, blah, blah. And since our topic is similar triangles, we will try to use the similarity. So to do this one, let me just actually add some lines again. Okay, so from here, I just extend this. Okay, just extend this line, this direction. Okay, and also extend this line. Okay, from here, just write in this one so it will be straight. Okay, something like this. So now let me draw a line that is parallel to AD. Okay, so now if you draw a line that is parallel to AD, so it will be, what is it, from here. So how can I do this? Maybe this, something like this. Okay. Okay. Maybe it looks somehow. Okay. Let me just draw a line that is parallel to AD. So ABCD, suppose that this side, ABCD, so this one is, let me use blue, ABCD, so this point, let's say it is E, okay? And this line segment is parallel to this. And suppose that this angle is alpha, and also it is alpha, it is given. And since EB is parallel to AD, right? So that means that also this angle must be equal to alpha. Okay, so, and also another thing is from here, see here, this AB, right? AB and EB is parallel to ED. So AB is a line segment. And what is it? This alpha, right? Actually, angle, let me just write here, angle DAB, DAB should be equal to angle ABE. Why? Because they are alternate angles, not triangle, they are angles. Let me just write it like this. Okay, because if you just draw two parallel lines, right? If you draw a line, so this angle is alpha, and also this angle should be alpha. And that's why EB is parallel to AD, and angle DAB is equal to angle ABE. That means that also this angle should be equal to alpha. Okay. So what does it mean? It means that actually triangle AEAB is an isosceles triangle. So that means that if AB is equal to C, and also this part should be C. So now after that, I can write this, what is it? Relationship, right? Triangle CAD, triangle CAD, let me just write here triangle, is similar to triangle, what is it? CEB, right? Because it's parallel sides, they are equal. So from here now, we can just write that since these two triangles are similar, that means that the corresponding sides are proportional. CA over CE is equal to AD over EB equals CD over CB. So what is CA? Do we know CA? CA, right? What is CA? That's equal to B. B over CE. What is CE? That's equal to B plus C. AD equals, I don't need it, so okay, just let me just write this CD. What is CD? CD is equal to CD equals M. How about CB? CB equals M plus M. Okay, or if I just invert both sides of the equation, so here we have B plus C over B is equal to M plus N over and I can just separate this, right? Because denominator is the same. So I can just write as 1 plus C over B, because B over B is 1. 1 plus C over B is equal to 1 plus N over M. So dot, 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 and C over B equals N over M, which means that B over C is equal to M over M. So now dot, 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 that's why B over C is equal to M over M, or B over M equals C over M. That's the proof of angle bisector of a triangle. Dasha, let's give 1 minute break. I'll just bring my tea and we will continue. Okay. Question 2, here we have question 2 and question 3. All right, question 4, parallel ABC, point of AC, okay, triangle, and 7, 8. Okay, so loud. So let's continue. I think we can just do only 2 and the rest you'll practice. Maybe next week we have more time. We can also do some more questions because in geometry, proving stuff, it takes a lot of time. So what can we do? So in this question, in the figure, DE is parallel to FG is parallel to BC. And the ratio of AD to DB is 2 to 3. And BE, CD, and FG meet at H, as seen. And the question is, what is the ratio of DI to IG? So we have to find the ratio of DI to IG. Whereas DI is there, DI and over IG, that is there. Okay, so again, first, of course, we need to write the similar triangles and we'll try to find the relationship. And okay, first, since DE is parallel to FG is parallel to BC, first I can write this triangle ADE. Triangle ADE is similar to triangle AFG is similar to triangle ABC. Okay, so DIIG, let me just write here DI, let's say it's equal to A, and IG, let's say is equal to B. So DIIG is, we have to find this, A to B, simply A over B. Okay, so also we have some other similar triangles, and since see here triangle DIE, right, is what is it? Is, let me just write here some other triangles, and I think I don't have to write them. Triangle FBH is similar to triangle DBE. At the same time, triangle HCG is similar to triangle DCE. Okay, so these are the similar triangles. Also, at the same time, triangle DIE is similar to triangle GIH, right? And Yeah, that's it, I think. Okay, these are the similar triangles. Okay, so what can we write here? So from here it says that AD to DB, AD to DB is 2 to 3. That means that if AD is equal to, let's say, 2x, right? This FB should be equal to 3x. And also this FD, I don't know, let's say it is T. So this remaining part, FA, it will be 2x minus T. Okay, because every time I think BF and blah, 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 it may be a little bit confusing. Okay, how about DH? Okay, HC. So, okay, DH over HC equals FD over FB. I can just write these ratios. So now first, let me just try to write some ratios here. From here, AD, right, from this similarity, for example, AD is similar to AFG. So from here, AD over AF is equal to DE over FG equals AE over AG. Okay, and also I can write this one. How about AFG, ABC, ADE, ABC, AD over AB equals AE over AC equals BDE DE over BC. Okay, in this one I can just write this. If I write everything, it will be a bit complicated. So from here, let me just write, since triangle DIE is similar to GIH, right? From here, I can just write here DI over IG. So that is, just write here, A over B, right? So that's equal to EI over IH, I don't need it, or and DE over HG. So that's equal to DE over HG or GH. Okay. So now at the same time, also actually this ratio, right? This DE over BC, that's equal to 2 over 5. So now from here, we also can write here DE over BC, that's equal to, and AD over AB, that is 2x over 5x, which is equal to 2 over 5. Okay. So now from here, I have DE, right? I can find DE. What is DE? DE is 2 over 5 times BC. So from here, dot, 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 DE is equal to 2 over 5 times BC. Okay. So now, how about BCGH? BCGH. What is GH here, right? How can I write here? From here, actually, what is it? GH over this equals this over this, or GH over BC. Okay, BCGH. How can we have connection? How can we connect this? BC over GH is equal to 2x minus T over 2x. So, because if I just continue here, that's equal to, and D equals 2 over 5, 2 over 5 times BC. So here we have BC over GH. I'm just trying to find this BC over GH. And BC over GH, right? BC over GH. Okay, BC over GH is equal to, or this over this, this over this equals this over this, or equals t over 2x. So we need to find 2x. Okay. So just continue from here. So from here, I can just write, since triangle EHG is similar to triangle EBC, so here we have GH over BC is equal to EG over EC. So that means that this T over this part is, what is dB? That is 3x. Or we can just write here from here BX over, actually BX over GH. So BC over GH is equal to what is it? 2x. This 3x, right? Divided by 2x. So it should be 2x and 3x. This should be 3x over t. Okay. So actually this should be 3x because BD is 3x minus t. So it will be 3x over t. Okay. So the question is, how can I find x over t? Okay, now from here, you can just write here 2x over t. That is this over this. 2x or ft. Right. Parallel lines. Okay, they are equal. This over this. X over t. We have to find x over t. Okay. X over t. This over x over t. Similarity. To x over x plus t dE over fg. So 2x over 2x plus t equals dE over fg. And 2x plus t, 2x plus t over 5x equals fg over bc. fg dE bc. dE bc, that's, okay, we know that's g or G, GF, GH. FG. FG is GH. 5x over 2x plus t equals BC over FG is GH HF. GH plus HF. BC is equal to 3x over t. BCFG is BCFG. Anyway, that's how we are stuck here. Okay. So maybe next week we'll continue from where we stopped. I don't know how to go from here. Dasha, thank you very much for this week. Next week we will do some test questions, and also maybe if we have more time, I'll try to solve 1 or 2 questions from exercise 3. So this exercise 3 questions a little bit, it's about proving. That's why it takes time. That much is enough for this week. Okay, have a nice weekend. I'll see you next Sunday. Okay, bye bye.
Bye and thank you, sir.
Thank you.